Hi, I'm Andy, and this is my lesson on creating an array list in Java. In this lesson, I'll discuss the differences between arrays and array lists. I'll then show you how to create an array list using generics. Let's get started. Let's start this lesson by creating a class called student. We'll add a few instance variables, a constructor, accessor methods, and a toString method. Now, suppose over in main, I want to make a group of student objects to represent the students enrolled in a course. In previous lessons, we learned how to do that by making an array. So let's make an array called enrolled students, like this. The problem is, I don't know what to put here for the size of the array. The number of students enrolled in a course changes as students add and drop the course. So we need to allow the size of the array to change as the program runs. But the size of arrays in Java is immutable. Once you make them a certain size, they can neither grow nor shrink. That means an array is not the proper data structure for enrolled students. Instead, we want to use a structure that is similar to an array but can grow and shrink in size. That data structure is called an array list. Let's check out the ArrayList API so we can understand how to use it. The first thing I want you to notice is this right here. This is the name of the package that contains the ArrayList class. A package is a collection of classes. Apparently, the ArrayList class resides in the java.util package. When you compile a Java program, the compiler needs to locate the code for all the classes you use in that program to ensure you're using each class correctly. Besides looking in your own program for those class definitions, the compiler will also look in a package called java.lang. If the compiler can't find a class you use in either of those two places, it reports an error. For example, the string class is defined in java.lang, and the student class is defined in our own program. So we can use both of those classes in our program without any problems. But the ArrayList class is defined in the java.util package. So if we add it to our program, the compiler won't be able to find it and will report an error. To fix this problem, we need to tell the compiler where to find that class. We do that with an import statement, like this. This line of code is telling the compiler that it needs to go to the java.util package and grab the ArrayList code in order to successfully compile our program. Anytime you want to use a class that's not defined either in your own program or in the java.lang package, you need to include an import statement like this one. Back in the ArrayList API, notice we have three constructors we can use when making an ArrayList object. Typically, we'll want to use this one, the noArgument constructor, which creates an empty array list. Let's do that. Now let's make three student objects and add them one at a time to the array list. In my next lesson, I'll explain ArrayList methods in more detail, but for now, we'll just add them using the simple add method. When imagining how an array list is stored in memory, I want you to picture them just like you do an array. Our array list doesn't actually contain student objects, it contains references to student objects. Now let's print the contents of the array list. Fortunately, the ArrayList class has a toString method that does that for us. Notice how the ArrayList toString method invoked the student's toString method. So we get a nicely formatted list showing us all the details of the student objects contained in enrolled students. Now let me show you one annoyance with ArrayLists and how to fix it. ArrayLists are more flexible than arrays. They can contain all student objects, as in our case, but they can also contain a mixture of different objects. 3 student objects and a string object, for example. The downside to that flexibility is that once you grab an object from the array list, the compiler doesn't know its exact type, because it can be any type of object. Here's what I mean. To get an object from an array list, we use the get method and pass the index. So to get the first student object in the array list, we pass 0 in the get method and assign its return value to a student reference variable. We can then print that student's info. This code certainly looks like it should work. The object at index 0 is indeed a student object, so assigning it later on to a student reference is correct. Let's see what happens when we compile this code. This error here indicates that the compiler doesn't know for sure that the object at index 0 is actually a student. All it knows is that it's some type of object. This may seem weird since up here we explicitly put nothing but student objects into the array list. But the compiler simply isn't smart enough to make that connection, so it can't be sure that this line of code is correct. To fix the problem, we can tell the compiler to treat the object obtained from the array list as a student object. We do that with a cast, like this. Now our code should work since we're casting the object obtained from the array list to a student before assigning it to a student reference. Let's see. So that fixed our error. But there's 2 problems here. One is that it's kind of a pain to have to use a cast every time we grab a student object from our array list. The other is that enrolled students is meant to contain only student objects. We shouldn't allow any other type of object to be added to the array list. Whenever possible, we should explicitly prevent things from happening if we don't want them to happen. We can solve both issues using something called generics. Generics have several purposes in Java, but the one we want to focus on here is their ability to restrict what kind of object is put into an array list. To do that, we simply put the data type for the array list objects inside of 2 angled brackets right here and right here. Now this array list can only hold student objects. That means we don't need to use the cast. Let's see. And if we do try to add a different type of object to the array list, we'll get a compilation error. Inside these angled brackets, we can put any type of class we want. However, we can't put a primitive data type like int or double. Let me show you that. This produced an error because array lists hold references to objects. They can't hold primitive values. That seems like a huge restriction, since there are many times when we want an array list to hold a group of numbers. Fortunately, there's an easy way to do that using the integer and double classes. But that's a topic for a future lesson. And that wraps up this lesson on creating array lists in Java. I'm Andy. Thanks for watching and coding with me today.